Assalamu alaikum. My dear cadets of class 9, I welcome all of you to my online physics class of Bodishal Cadet College. During this ominous cloud of COVID-19, you are not able to stay at your second home, so your academic program is being hampered. That's why this online effort that has been taken by the authority of Bodishal Cadet College to carry on our learning process. My dear cadets, you know very well that we are passing through a very crucial time. So you should not go outside of your home. You should stay home, stay safe. Before commencing my class, I would like to introduce myself. This is Muhammad Kamruzzaman Khan, lecturer, Department of Physics, Borishal Cadet College. This class for class 9 cadets, subject physics, chapter number 4. Name of my today's chapter is work power energy. Dear cadets, you should observe this image and try yourself what should be our today's lesson. Yes, our today's lesson is different source of energy, transformation of energy, power, and lastly, efficiency. Learning outcomes. By the end of my today's discussion, cadet, you will be able to explain different types of source of energy, explain the transformation of energy and how its use hampers the balance of environment. Explain the mass energy relation, establish the relation between transmission of energy and power, measure the efficiency. Key point of my today's discussion: non-renewable energy, geothermal energy, renewable energy, hotspot, biomass, biogas, power, megawatt, and efficiency. At a glance, what I have discussed in my previous class, since it is the continuation of previous class, that's why I have discussed in my previous class work, types of works, energy, kinetic energy, and potential energy. Let's have a closer look towards the forms of energy and its transformation related discussion. At first, I am going to discuss about different sources of energy on the basis of nature. Energy is the ability or capability of doing work by a source. Energy is the driving force by which we can do anything. So there are different sources of energy. Firstly, energy is divided into two forms: renewable energy and non-renewable energy. Renewable energy is one type of energy that can be reused again and again. Here, renewable energy is classified into some forms. Firstly, hydroelectricity, biomass, solar energy, wind energy, and geothermal energy. Later, non-renewable energy is divided into oil, gas, coal, and nuclear energy. renewable energy and non-renewable energy. I can define non-renewable energy in such a way that the sources of energy which we can use again and again is called renewable energy, and the example of renewable energy is solar energy, tide energy, and air energy, etc. Non-renewable energy, the sources of energy which we cannot reuse or we cannot use repeatedly, is called non-renewable energy. Example of non-renewable energy is coal, petroleum, gas, nuclear energy, etc. Sources of renewable energy. Firstly, I'm going to discuss about biomass. Biomass means wood, fuel, straw, etc. Biomass refers to all those organic material that can transform into energy. A small fraction of solar energy is transformed into chemical energy by the green plants in the process of photosynthesis and remains stored as biomass in different parts of the tree. Biomass is mainly composed of carbon and hydrocarbon. This is renewable sources of energy. This is renewable sources of energy because the trees can be grown again. It is not lost forever from the world like oil, gas, and coal. That's why biomass is called renewable energy, and it is the form of hydrocarbon. Okay, let's see the picture. Biomass, then from storage, then from preparation and processing, and this is the main part from which we can get biomass. And by this process we can get electricity, and electricity is produced from the generator. Okay. Biogas. Combustible gas used as cooking gas and producing light, which we get from mixture of cow dung or agriculture communities. The ratio of cow dung and water will be 1:2. For the cooking and lighting bulbs for a family of 4 or 5 persons, the requirement of gas can be supplied from the cow dung of only 2 or 3 cows. Later, I'm going to discuss about hydroelectricity, and this is the very important part of our today's discussion. What is hydroelectricity? The electricity that can be produced by the use of water is called hydroelectricity. Hydroelectricity comes from the water. Okay. Most of the part of renewable energy is hydroelectricity. To produce electricity by making a dam in a river, since the water of a river is inexhaustible, therefore the source of energy of such a power plant is inexhaustible. This is the conventional concept. Let's have a closer look towards a video on hydroelectricity.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro.
Okay. Next, wind energy. After solar energy, wind energy has occupied an important place very quickly. In our country, we are not familiar seeing large turbines for wind energy, but in many countries of Europe, this is a very familiar scene. The place at which the windmill is set up, a large tower is erected upwards. So there is no waste of land at all. For this region, the environmentalists like it very much. From a wind turbine, it is possible to get a few megawatts of electricity. The utility of the energy that is generated by using air is increasing by 30% every year. This number is not a very small number at all. Okay. Next, geothermal energy. This is very important energy of renewable energy. Pieces of rock melted by heat, and these rocks are preserved inside of our land or earth. The melted rock is known as magma. The place where it will remain stored is called hot spot. When water comes in contact of hot spot, then water turns into vapor, and it is very difficult task for us to find out the hot spot. After finding the hot spot, turbine is placed at hot spot. Vapor is converted to kinetic energy. By using turbine, we are getting electric energy, and this electrical energy is collected from this geothermal energy. Let's have a closer look towards a video on geothermal energy.
Geothermal energy, the energy that exists in the form of heat inside the earth, is geothermal energy. In some regions, magma moves upwards and gets collected at some depth below the surface of the earth. These places, known as hot spots, are the sources of geothermal energy. The underground water coming in contact with these hot spots boils and turns into steam. Since this steam is trapped between rocks, its pressure increases. This steam is extracted by linking pipes through holes drilled up to hot spots. This steam turns the turbines of electric generator and produces electrical energy. In India, geothermal energy is available in Madhya Pradesh. Geothermal power plants are operated in New Zealand and America.
Before starting non-renewable source of energy, I should say something about previous video, that is about geothermal energy. From this video, it is very much clear to all of you that the hot spot and magma are located inside of the earth, and after finding hot spot, we will be able to find out, or we will be able to extract electricity from this hot spot. Now Non-renewable part. Nuclear energy is the source of non-renewable energy. There are two types of nuclear reaction. From these two nuclear reaction, we are getting non-renewable energy, that is nuclear energy. One is fission and another is fusion. What is fission? The process in which a heavy nucleus splits up into two nuclei of nearly comparable masses and emits enormous amount of energy is called nuclear fission, or the nuclear reaction from which the obtained energy is used to produce electricity is called nuclear fission. Let's see the reaction. Yes, this is an isotope of uranium 92 and 235 is heated by the neutron. After heating, this uranium 92 is split into barium and krypton with 3 neutron and enormous amount of energy. And this energy is 200 mega electron volt. Boys, it should be noted that the amount of energy is 200 mega electron volt and it is emitted from only one nuclear fragment. And mega electron volt is the another unit of work or energy. Next, fusion, the process in which more than one lighter nucleus are combined together to form a relatively heavier nucleus and release tremendous amount of energy. That process is called nuclear fusion. Let's see the reaction of nuclear fusion. Nuclear fusion, here there are two isotopes of hydrogen. After combining these two isotopes of hydrogen, we are getting helium and one neutron and some amount of energy, that is 17.6 mega electron volt. And this nuclear fusion reaction is always happened in our sun. Our sun is always losing its mass, and this mass is converted into energy, and by this reaction we are getting this sunlight. Nuclear reactor. Nuclear reactor is a device. Here, nuclear chain reaction is controlled. By this controlling chain reaction, we are getting energy, and this is nuclear energy. So boys, we can define nuclear reactor. A nuclear reactor is a power plant where nuclear reaction takes place. Obviously, there is a reaction, that is nuclear reaction, that is taken place, and it should not be nuclear fusion, it should be nuclear fission. Remember it, that is nuclear fission, not fusion. Transformation of energy. Energy can be transformed from one form to another form. Here, heat energy. Steam engine is one example of heat engine, and this heat engine we are getting mechanical energy. Electrical energy, from bulb, electric energy is being converted into light along with heat. Mechanical energy. Hydroelectricity is the example of mechanical energy. Here, potential energy is being converted into kinetic energy, and this kinetic energy is using to run the turbine, and from this turbine we are getting electric energy. Now, nuclear energy, nuclear power plant is the example of nuclear energy. Nuclear to electric energy is being got here. Chemical energy, we are having food. From this food, chemical energy is being converted into mechanical energy, and by using this energy, that means we are doing different types of work. Magnetic energy is one kind of energy. By using this energy, we are doing different types of work. That is, the motor is the example of magnetic energy. From this motor, we are getting mechanical energy. Light energy. Photographic plate. From photographic plate, light is converted into electric energy. Sound energy. Washing machine is the example of sound energy. Here sound is used to, and this sound is converted into mechanical energy. Solar energy. Solar energy is the most important renewable energy, and solar panel is the example of solar energy. From this solar energy, we are getting electric energy. Let's see the power and efficiency related discussion, and it is very important part for your lesson, today's lesson, boys. So you should concentration, you should put your concentration here. Mass energy relation. Einstein said that mass of an object and energy are identical things. Mass can be converted into energy, or energy can be converted into mass. So this is very important or famous equation that has been given by Einstein. E is equal to mc square. Here m is the mass of an object and c is the velocity of light. Here the amount of velocity of light is 3 into 10 to the power 8 meter per second. Okay, I am going to clear your concept about mass energy relation by using a math. Suppose the rest mass of an electron is 9.1 into 10 to the power minus 31 kg. So we are going to find out the equivalent energy from this mass of electron. Let's see. We know E is equal to mc square. After putting the value of m and c, we are getting the result, and this is the equivalent energy of this mass. Now I'm going to discuss about power. What is power? Power is the rate of change of work done. When someone does any work as quickly as possible is called his power. Power is defined by P, and it is W by T, and W is mgh because this is potential energy. So W is equal to mgh over T. T is time. The unit of power is joule per second or watt. So 1 joule per second is equivalent to 1 watt. But you can use only one unit among or between these two units. And horsepower, HP, is symbolized for horsepower. 1 HP is equal to 746 watt. Dimension. It is very most important question for MCQ. What should be the dimension of power? Okay, boys, I'm going to discuss about the dimension of power. Let's see. Dimension is defined by square bracket. So this is the equation of power, mgh, and the dimension of m is capital M. G, acceleration due to gravity, is L T inverse 2, and dimension of h is capital L and capital T for small t, that is time. Then we are getting the final form of dimension of power, that is ml square T inverse 3. Boys, you should remember it because it is important, very important for your MCQ. Let's have a look at a video on power.
In today's video, we're going to take a look at what power is and see how we can calculate it. Now, although they both mean pretty much the same thing, it's important to know that there are actually two different definitions for power, each with their own equation. One is that power is the rate at which energy is transferred, which can be shown by the equation power equals energy transferred divided by the time it took to transfer that energy. The other definition is that power is the rate at which work is done, and this can be written as power equals work done over time. Now, the term work done can be a bit confusing, but basically it's just a special measure of the energy transferred, and is used when a force is used to move an object by a certain distance. For example, if you pushed a car down the road, then the energy that was required would be referred to as the work done, as you moved it a certain distance. Whereas if electrical energy was transferred from a plug socket to your phone, we'd refer to that as just energy transferred, as there's no force or movement involved. In both cases though, power is measured in watts, energy transferred and work done are measured in joules, and time is measured in seconds. To see how the equations work, let's compare two lamps to see which of the two is most powerful. The lamp on the left transfers 1200 joules over 20 seconds, while the other one uses 1500 joules over 30 seconds. In this case, we'd be using the energy transferred version of the power equation, as there's no work being done. For the left lamp, we'd do 1200 joules divided by 20 seconds to give us 60 watts as the power. And for the right lamp, we'd divide 1500 joules by 30 seconds to give 50 watts. So we can tell that the left lamp is more powerful. If you look on your lamp at home, there may well be a label telling you its power.
Next, I am going to discuss about efficiency. Efficiency is the ratio of effective energy and total energy or input energy. Efficiency is expressed in percentage, and it is defined by a letter that is eta. Eta is equal to effective energy divided by total input energy is multiplied by 100%, is equal to P output divided by P in into 100% is equal to E output divided by E input into 100%. Boys, you should remember that efficiency should be the ratio of same quantity but not different quantity. So you cannot use P output divided by E input or E output divided by P input. You must have used only P output divided by P input or E output divided by E input. Here, P output means output power, P in means input power, E out means output energy, E in means input energy, and finally P output is equal to mgh divided by T. You know it from our previous discussion on power. Here W is equal to work done, T time, G acceleration due to gravity, and finally H is equal to height. Let's have a look towards the video on efficiency.
Now, in order to look at efficiency, I'm just going to do a quick investigation with this tennis ball. And what I'm going to do is I'm going to drop it from a certain height. So here I've got something which has got 10 equally sized sections. Now, if I drop it from the top, it bounces up to about this height, which is kind of sort of 5.5 sections high compared to the original 10. Now, I could do the investigation again, but using maybe a different kind of ball. So this is a steel one. Okay, that bounced a little bit, maybe up to about there. I could also, do the same thing with other kinds of balls. I've got a beanbag here that doesn't bounce at all. Now, when we come to think about efficiency, it's really just a measure of how much of the energy has been transferred usefully. Now, we're going to say for this example here that the useful energy transfer is the amount of gravitational potential energy stored after its first bounce. Now, it started at 10 sections high. It ended up bouncing to 5.5 sections high. So we can then say that this has got either an efficiency of 55% Or also we could give it a number between 0 and 1, in this case 0.55. And that's all efficiency really is. It's just the ratio of how much energy we had at the start to the amount of energy that's been usefully transferred. So there's two equations we can use. The first one is looking at the amount of energy transferred, and we're thinking about the total amount of energy that goes in compared to the useful amount of energy that comes out. And the other thing we can do is we can look at the power, because power is just the rate of energy transfer, and therefore we can maybe think about the power input to something compared to the power output. And effectively, the more efficient things are, the less wasted energy there is. And again, energy is not created or destroyed, it doesn't disappear. It's just that this wasted energy is often transferred to a different energy store that's not really useful for what we want that thing to be doing. So that's just a little bit about efficiency.
My dear boys, I think after observing this video, your concept about efficiency is very much clear. Now I'm going to discuss a math about efficiency. This math is like that. Okay, let's see the solution. Efficiency is equal to P output divided by P input into 100%. Now P output is equal to mgh divided by T. Now we are getting the value of P output after putting the value of mgh divided by T, and it becomes 9800 watt, and P input is equal to 12000 watt because it is given in our math, and it is input power, that is 12 kilowatt. 12 kilowatt is equivalent to like that. Now we are getting the efficiency of this motor is 81.67%. Boys, I have a question to all of you, that you must think the efficiency of an engine or motor can be 100%. Can be 100%. Okay, let's start to find out the result. Some explanation. I have inserted here some important explanation. 1 kilowatt is equal to 1000 watt. 1 horsepower is equal to 746 watt. 1 kilowatt hour is equal to 1 unit, and it is board of trade unit for measuring or calculating electricity all over the world. 1 kilowatt hour means the energy that a machine with a power of 1 kilowatt uses in 1 hour. 60 watt or 60 joule per second is written on the surface of a bulb. What do you mean by this? This means this bulb transforms 60 joules electrical energy to light energy and heat energy in 1 second. 200 megawatt power of a power station means this power station supplies 200 into 10 to the power 6 joules per second energy in 1 second. 30% efficiency. What do you mean by 30% efficiency? 30% efficiency means this machine up to 70% of its energy is lost as heat energy, and at last only the 30% of input energy is transformed into usable electrical energy or any forms of energy, and the forms of energy will depend on the type of machine. And finally, 200 mega electron volt is equivalent to 3.2 into 10 to the power minus 11 joule, and it is very burning question to all of you. You have to find out, or you have to learn, how can you find the value of mega electron volt into joule, and this is the process. Okay, have a closer look here. At a glance, what I have discussed today. Yes, I have discussed renewable energy, non-renewable energy, transformation of energy, nuclear reactor, power, and finally efficiency. Now, some sorts of questions are inserted here on the basis of today's discussion. Firstly, knowledge-based questions. What is power? What is efficiency? What is renewable energy? What is non-renewable energy? What is hydroelectricity? And what is geothermal energy? Comprehension-based questions are inserted here. Please have a look. And you should try your level best to solve these questions. Now, let's see the home task. At first, a STEM or CQ question is inserted here. Look at the CQ questions, and you know it very well that CQ question is a combination of 4 types of question. Question A, knowledge-based questions. Question B, comprehension-based questions. Question D, application-based questions. Question C, application-based questions. Question D, higher ability-based questions. So next, we can see MCQ sample questions. Here, some MCQ question is inserted. You should look into it and try your level best to solve these questions. If you face any difficulty, please inform me and I'll try my level best to answer your question. Boys, if you have any query about my today's discussion, please write in inbox and I will try my level best to solve your questions or answer your questions during my class. My dear boys, it is our concern. We are going through a very crucial time and the intensity of corona is increasing day by day. So you should not go outside of your home. You should stay at your home, stay safe, stay blessed. Thank you.